Good day, everyone. In this tutorial, I will demonstrate how to create an Arduino project called Tone Plays, pitch changes of 3 buttons. We will be using the Arduino Uno R3 in Tinkercad to simulate how different buttons can produce different sound pitches using a buzzer. This project will also include a potentiometer to adjust pitch sensitivity and resistors for stable wiring connections. Our goal for this activity is to construct a circuit where each button plays a unique pitch, for example, one for low tone, one for medium, and one for high. When the user presses a button, a buzzer will generate a sound using the tone function in Arduino. This simulates how music notes or sound effects can be controlled through code. Let's identify all the components we will use in Tinkercad. We need the following: 1 Arduino Uno R3 board, 3 push buttons, 1 potentiometer, several resistors for each button, 1 piezo buzzer, and a breadboard with jumper wires. Each of these components plays a role in building a functional tone player. Now, let's begin constructing the circuit. First, place the Arduino Uno R3 and a breadboard side by side in your workspace. Next, drag 3 push buttons onto the breadboard. Connect one side of each button to digital pins 2, 3, and 4 of the Arduino Uno. These will be our input pins for detecting button presses. Next, connect the other side of each button to GND using 10k ohm resistors. These resistors act as pull-downs, ensuring that the input reads low when the buttons are not pressed. This prevents random signals and makes the reading more stable. Then, place the buzzer on the breadboard. Connect the positive leg of the buzzer to digital pin 8 and the negative leg to GND. This pin will output the tone signal. Finally, connect the potentiometer. Its middle pin goes to analog pin A0. One side goes to 5 volts and the other side goes to GND. This will allow us to change or control the tone variation later in the program. Once all components are connected, double-check every wire. Ensure that the buttons are properly linked to the correct digital pins, and that the buzzer and potentiometer have stable power and ground connections. Tinkercad wiring accuracy is crucial because even one misplaced wire can prevent the code from working correctly. Inside the loop section, use if statements to check which button is pressed. For example, if button 1 is pressed, play a tone of 262 Hz. That's the note C. If button 2 is pressed, play 294 Hz, which is the note D. And if button 3 is pressed, play 330 Hz, which represents the note E. Each tone will be created using the tone command, followed by the pin number and the frequency value. Now, let's move on to programming. Click the code button and select blocks plus text mode. We'll be using block coding for easier understanding. Start by creating 3 input blocks for the 3 buttons and 1 output block for the buzzer. To make our project more dynamic, let's use the potentiometer to adjust tone values. In the code, add the analog read AO function to capture the potentiometer's reading. You can map that value to change the buzzer's pitch slightly. This allows the user to control tone sensitivity or create smooth pitch transitions while pressing buttons. After adding the potentiometer, your code should now detect which button is pressed, generate a tone from the buzzer, and adjust that tone's pitch using the potentiometer. Make sure to stop the tone when no button is pressed by using no tone. 8. This prevents unwanted buzzing and makes the sound clean. Now, click Start Simulation. Press each button one at a time. You should hear a different tone for each button. The potentiometer will also influence how high or low each pitch sounds. If the buzzer doesn't produce any sound, check your wiring and the digital pins in the code. Notice how pressing each button triggers a unique sound frequency. This shows how Arduino can produce musical tones and sound effects. The potentiometer acts as a modifier, allowing the user to fine-tune or bend the pitch, similar to an instrument. This experiment demonstrates how inputs like buttons and potentiometers can control outputs such as buzzers. To summarize, we successfully constructed a Tone Plays project using 3 buttons for input, 1 potentiometer for tone adjustment, and a buzzer for sound output. Through correct wiring, block coding, and simulation, we learned how to create multiple pitch variations using simple electronic components. This project helps students understand how digital signals, analog inputs, and output devices work together in Arduino programming. Thank you for watching, and I hope you enjoyed learning how to make this sound-based project in Tinkercad.